Good morning to everyone. If you want to check if you are in the right room, this is the title of my talk. Wait. Oh yeah, this is more realistic. Because as I will explain, yes, MySQL, just like any database, can be a great tool, but it can also be a heavy bottleneck. Okay, this is the canonical slide about who I am. If you want to ask me something tomorrow, in the next days, that is my email. Basically, I will talk about MySQL, but actually everything I will say, maybe with some exceptions that I will mention, applies equally to Percona Server and MariaDB, which basically are forks of MySQL. And actually, with some changes, it also applies to any other relational database. Since I start with this slide, may I ask who of you uses MySQL? Who uses Percona Server and is aware of this? Okay. Who uses MariaDB? So most of you are on the MySQL side, but there are some people on MariaDB and just a few on Percona Server. Anyway, they are basically compatible. So again, everything more or less will apply to all variants of MySQL. This talk is not about this list of things. It is not about ORMs, sorry. You will have to find out how to apply what I say to the ORMs you are using. This will not show PHP code, because you know PHP much better than me. It is not entirely true that I will not talk about query optimization, but I will talk about just a small part of query optimization. I will not mention SQL mode, not because it's not important, but because changing the SQL mode affects too many things. It affects which queries are valid, which return errors, which syntaxes you can use sometimes. So basically, you cannot just decide to change it in production, and it would be useless to talk about it tonight. There are more interesting topics. I will not mention MySQL characteristics that I don't want to talk about. There are reasons for that, but you can ask me questions, even if I don't want you, and I will still say thank you for the question. No, actually, a bit more seriously, I appreciate questions. So whenever you have questions, just interrupt me, raise your hand, or shout. But actually, the first legitimate question would be, why talking about MySQL at a PHP event? So this question can be divided in smaller parts. So why MySQL? Well, as I mentioned, the database is a complex piece of software that can be a powerful tool, or it can be a bottleneck. But if you think more about it, all applications, starting from the Van Neumann machine to everything you can write today, just works with data. They accept data as input, they elaborate data, and they produce some data as output. Okay, a simple program doesn't need a database, of course, to do all this. But when you work with complex data or with a high quantity of data, actually you will need a database. Why at a PHP event? Well, PHP is basically, as far as I know, the standard for the web. So it's the most common language, as far as I know. Just like MySQL is the most common database used in general in the web, and not only in the web. If you think about it, there are reasons for that, because they came up in the same period and more or less in the same way. MySQL is a bit older, but before the 90s, it was basically a toy. Even before the 2000, probably it was almost a toy. But they both came out because they were open. Oh. This was prepared. I will try to be faster so it doesn't happen again.
Like after a couple of minutes. Quick.
Thank you. So, okay, they were open source and they came up in the right moment, because it happened when the internet, or the www, was born. So the first internet and the open source movement share a lot of values, because they both are about free exchange of information, free sharing, and so on. So it was quite logical to use MySQL and PHP for websites. Also, they were very simple at the beginning, and the first websites were also very, very simple. With time, of course, websites grew, they become more and more complex, but the same happened to PHP and MySQL. So I see a strict relation. I think it's not working anymore. Oh, okay, thank you. So let's start with some good practices for your development machine. So I guess that most of you at least have a development machine with MySQL installed. So you have full control of it. You have a configuration file, which usually is that one. And I think that it is a good idea to set 3 settings. The first one simply enables the slow query log. The second one defines the threshold when a query is considered slow, and therefore it is logged. If you set it to 0, you will log all queries. And I think it is a good idea, because then you can inspect exactly what your application did after each test. Performance schema is something that enables some system tables, and later I will show you a couple of queries that require this. Okay, so first of all, the slow log is usually in the data directory of MySQL. If you use Linux, just run that. Otherwise, you saw my email, just write me and ask me how to do it. Okay, so first, before each test, you can just send empty string to the slow log, so basically it becomes empty, and then you run your test, of course, and then you check all queries you executed. You will see that there are of course, the query text, but also how many rows were returned, how much time they took, some details on execution, and blah, blah, blah. Performance schema. Okay, there is one particular table that I will suggest to inspect from time to time, and you can run a truncate table. You know this command? Okay, basically it just empties a table. You will empty that table, you will run your test, and then you can run a couple of queries to see what happened. So I will share this somehow, don't worry. You don't need to copy everything now. basically, this query just shows all the queries that were executed, but they failed with an error. Notice that you can even replace from time to time some errors with some warnings if you care a lot about the quality of your queries, and you will see warnings, for example, about wrong data type conversions and so on. Division by zero, attempts to insert long data into small columns, and so on. Okay, this shows the queries that were executed, but each time they were executed, they returned no rows at all. Okay, you probably are thinking, I don't run such queries. If something don't return any results, I will not use it. Actually, almost every time I put my hands on some company's production database, I see a lot of queries like this. So yes, running this query will probably show you that you are running some query that is useless. But even if it returns nothing, it will just consume server time and add work to MySQL. So it's always a good idea to avoid useless queries. Or you can also query the same table to find queries that are not optimized. This is a big topic. I just show a small example here. In this particular case, we are looking for queries that don't use an index at all, and queries that create temporary tables on disk. I will not elaborate on this, sorry, because there is no time in an hour to explain these things. Okay, so these were just practices that I suggest, but let's start with the real topics. And let's start with indexes. Everyone knows what indexes are? Okay, I don't see low hands, so I will suppose that you will know it. But I will still explain it, because maybe you never heard this explanation. What is an index? It is a phone book. A phone book is just a data structure with ordered rows. Okay, rows are name, surname, address, phone, and basically the index is not a real index, but still it's a virtual index because the phone book is ordered by last name and then first name. And yes, the order of columns in an index matters, because imagine a phone book ordered by first name and then surname. It would be completely useless. You will find out with the next slides that your mind contains a pretty good SQL optimizer. I will show you. Just remember, when you don't know what an index can do, think to the phone book. So these are examples. Even if the room is big and you are quite many, maybe I want to try to keep it interactive and ask you some questions. Who thinks that the first query can use an index? Okay, you are the first one who raised it. And do you also think that the second query can use an index? Yeah. How can it? Can you use the...
Is the question if they're using the same index?
There is, in a phone book, there is one index on the last name and first name. So it's basically a two columns index. Can you use a phone book to find everyone whose name is Tom? Well, you can, but you have to read it all.
Good. You wouldn't index, so something like Tom or Baker, you probably wouldn't index a name field because it's heavy, and there's too many things that are different.
Yeah.
You could add them, but they come at a cost.
Of course, you could, because you could find Tom if you read the whole phone book. But then you are not really taking advantage of the index. You are not taking advantage of the fact that the phone book is ordered alphabetically. That's the point. So in a relational database, the second query would just trigger a full table scan. Okay. The third query can use an index. Everyone agrees? It can.
Sorry, what was the
Ooh.
Gotta be quick. Okay,
Maybe if I can.
let's fix this.
Okay. I will just move the cursor from time to time, so.
It's okay. It's
Sorry, we're almost there. Okay. 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 Everyone agrees that you, as a human being, can use a phone book and find a guy called Tom Baker, right? Because you can easily find the surname because it's ordered. And once you find all the Bakers, they are ordered alphabetically by name, so you will find Tom easily, right? The fourth query is a trick. It doesn't matter in which order you write the conditions. The SQL optimizer is smart enough to understand. I see that there was some discussion about it. Okay, so first rule, there are just 4 rules to remember, and they are very easy. The first rule is a query can use a whole index or the leftmost part of it. So if you have an index on last name, first name, the query can use only last name or both last name and first name. Okay? You cannot just find all the Toms. You can, but it is a slow operation. So, which of these queries can be optimized? Everyone agrees that the first one can be optimized?
Yeah.
Okay. But what about the second? Who thinks that it can be optimized? Almost no one, but someone thinks it. So I will just say, think again about the phone book. Can you use the phone book ordered alphabetically to quickly find everyone who's not called Baker? Not really. You will have to read the whole phone book. You can find other ways to.
What do you mean by which can be optimized? What do you mean can you use an index to make it more efficient? Is that what you mean?
Yes. We're not taking advantage of the fact that the phone book is alphabetically sorted. So in a relational database, we are not using an index at all. We are just reading the whole table. Because it's faster than any other option. You will need everything except for bucket. So you just scroll the whole contents. Okay? But all the other queries can actually use an index. The third will find Backer, and from that point will scan everything in one direction. The other one, last name less than Backer, will do the same in the opposite direction. But in those cases, we are still using an index to find the rows we need. Okay? This is a special case. It would be more fun if there is a volunteer here. I'm not volunteering, I'm asking you to. Come on. Oh, great. Thank you. Do you think that the first query can use an index optimally? Okay. What about the second? Well, it is kind of a trick, but do you agree that it's basically like the first one, right? More or less.
Yeah, I guess so, because I don't know if it's smart enough to just look at B first and then
Yeah.
say, okay.
Yes, exactly, exactly. What about the third?
It can use it. Yes, looks like it should.
Yes, because it's exactly like the first two. Yeah, and the following one?
No.
Because it doesn't begin with a constant string, okay? And the same applies to the last. Great. I'm proud of you guys. So the rule 2 is simply you can use an index to find a value or a range, closed or open range. I mean, closed is between 2 points. Open is from 1 point to infinity. Okay? But you cannot find, for example, all values that are different from Becker. So let's see these queries. Another volunteer? Great.
Excuse me, and what so can be optimized means that these queries can use an index? Or?
Yes. Optimized means that it can run in the most quick way, which is reading an index, scanning an index or finding a specific point in an index.
Sorry,
Okay.
I've got a similar question. When we say optimized, are we, because what I'm understanding is the column indexed or not, right? And like what we're reading is queries, and the last name you were going to say, last name is indexed. It's a column that's indexed.
Yeah.
So when you say optimized, the column is already indexed.
The query is the table.
Optimize the query with
The table is indexed because it's like a phone book, as I said, right? So a phone book is ordered by last name and first name, and you can just imagine that it is a relational table with an index on 2 columns. Okay? And yeah, this is what I mean when I say optimized. Can the query use that index?
You say that you're actually getting the best out of that index.
Yeah.
You can index it, but it could be slow. But if you use it, you look at the very beginning and you look at a range.
Exactly.
You get the optimum performance out of it.
Exactly. Exactly.
Essentially avoiding scanning all of the indexes.
Yeah.
You can, but you are not doing it.
You wouldn't call that optimized.
No.
So you're right.
Yeah. Simply because it's as slow as reading the whole table.
MySQL database has a job to do. How can MySQL optimize your query to make it return quickly? So it index it itself.
Oh, no.
I'm sorry,
By the way,
in our case, we have indexed last name, first name, and optimized means that only the index is used to run that query.
yes. Yes. Oh, thank you. In the specific case,
Here, put my password in.
Okay. Okay, in the specific case, just imagine for a moment that you have two indexes, two separate indexes, one on first name and one on last name, just for this specific example. Okay? If you have a query like where first name equal Tom or last name equal Becker, can it use an index? Can it use both indexes or one of them?
No, you need to have a third one, which will...
No, I can use one. I should.
Because I guess each index is separated, so index, the first index the second.
But I can, when I scan, concern the first.
But in this particular case, the problem is the or. Okay, so you can you are asking MySQL to find the guys called Tom or the guys whose surname is Becker.
If
So,
I have two index, I can use it. If I have one index, I can't.
yes, exactly. But even if you have two, in most cases, MySQL will not use any of them. There is an exception.
Scan all.
Yes, because if it uses them both, it will have to use one index and run the query on it, copy the results in memory, read the second index. It's quite heavy operation. In most cases, it prefers not to use an index at all in this case, unless it is really a big table.
And what's the big table?
I cannot give you exact numbers because it really depends on a lot of things, on data distribution in the indexes, probably even MySQL version. So you should just test.
Depending on the data set.
Sorry?
It processes it differently depending on the data set, the size of the data set.
Yes. Yeah. Every case is different, so you will have to test. Okay. Maybe I can just move the cursor from time to time and.
For some reason, I can't change the value.
Mm-hmm. Oh, okay.
Is any like Mac screensaver expert out there?
You could just touch the trackpad or so. Go to power settings.
Yes. I've disabled like all the power settings. Like all of these are like. Is that on battery? Yeah, we know battery.
Okay, until now everything was clear. Are there questions maybe? So.
Maybe touch the screen.
Okay. Okay, great. Great. So the third rule is just or on different columns is not fully optimized, okay? As I shown. Okay, the last set of queries. Okay, another volunteer, please. Okay, the first query can use an index, right? Okay. And what about the second?
Yeah.
Okay. Because it's like using a phone book again, right? So you can find all the mnemois And once you find them, you can find the one called Leonard and then all the following, right? But what about the third query? Really? I mean, of course you can find all the guys whose last name is greater than Nimoy. But, and that's something, of course. But to find the ones that are also called Leonard, you will have to read them all, right? So what we say usually is that the first condition is optimized because it can use an index in an optimal way, but the second is not.
Isn't MySQL smart enough to find all the Leonards and then everything around that's greater than Leonard?
No, just because it can't. Well, probably it would also be a lot of work, but especially it can't because the index is not ordered by...
Like that.
But the index is ordered by last name and then first name.
Yeah, but the problem is then, if it reorders indices in the fly, it's AI.
Oh no. If it, yeah, theoretically everything can be done, but it will be slower than just finding Nimoy and then reading the following. Great. Okay. I said that I would move the cursor, but then I forgot.
There's a problem where I can't change that value. Does anyone know how to change that value?
Power saver. You go to settings and power saver.
Yeah, I've got on that.
Okay.
Is that the point? 5 bins. Every 5 minutes. Okay. There's no question.
Okay. So the same reasoning applies to the last query, right? Because again, I can find all the guys whose last name is greater than Nimoy, but then to find the guys whose first name is greater than Leonard, I will have to scan them all, right? The order of rows doesn't really help. It's the only way. Okay? So the fourth rule is the use of the index stop at the first range condition. So the third query is a good example. We have a range condition on last name, and therefore we cannot use the index optimally to find all the Leonards. Okay? The range condition puts a limit. Okay? So, enough with indexes. Let's talk about using proper SQL. All the following queries that I will show are about doing non-trivial modifications to the data, okay, in order to reduce the number of queries you run. I will show you. Okay, the first one is quite obvious, okay? I am afraid that even nowadays there are ORMs which do this thing when they have to run a join. Okay? They run a query on one table, they find the value they need, and then they look for that value in the second table within a loop. Okay? This is not optimal, of course, because you run a lot of queries, and every time you run a query, MySQL has to receive it, parse it, allocate memory, decide how to execute the query, and so on. Running just one join is much better. This is about duplicates. So, who knows already these commands? Okay, some of you, good. For the others, okay, you can insert rows in many ways. For example, these are the proper ways, in my opinion. So, the first case is good when you have to insert the row and you don't expect a duplicate to be there. If there is a duplicate, MySQL will give you an error and you will have to handle it in a proper way. If you expect that a row that row could already be there and you cannot insert a new one because you would insert a duplicate for the primary key or for a unique index, then you can add the ignore keyword. So a duplicate could be there. If there is a duplicate, you will receive a warning, but a warning is not an error. Does anyone know why in MySQL a warning is not an error? What is the different effect of an error? Exactly. We will talk about transactions later, but I hope that most of you know what I'm talking about. If you run the first query in a transaction and it fails, it will roll back the whole transaction. Let's talk about the third. The third is similar. I mean, you are trying to insert a product, but if the product is already there because the ID already exists, then you will update some columns. The last one is very similar, but there is an exception. Anyone knows the difference between insert on duplicate key, update, and replace? No. It's if a row exists, replace will delete it and then insert a new one. This means that if you have foreign keys or triggers, it's something different. Okay. Also, if you don't specify an ID, the new row will have a different ID. Okay. Okay, I talked about insert ignore. There are also update ignore and delete ignore, very similar.
Check the power option.
Sorry, guys.
Log out, right?
Yeah, it was a log out option somewhere in there. I think that was a screenshot from an older version though, so.
Yes.
Just keep wiggling the mouse.
Yes, sure. Okay, that's great. Okay, this is actually the next slide. Good. So the next example is when you have to insert many rows. Instead of running separate insert statements, you can run only one. Okay. And then another example is if you have to insert a row related to a row that you already inserted, but it's in another table, and you are using the auto-generated ID, but you don't know which ID was generated for that row, right? So normally people just run a select for that. You can avoid an additional select just by using this function. Okay?
Is that the ID on that table? Can you just put null?
Sorry?
Does null not do that as well? If it's an auto increment table, and you want the next, do you not just put null and then it automatically uses the last ID from
The last example. Yes, this particular function. Yeah. It works in a transaction, but also outside of transactions. Okay.
Would it be safe if you used it as two different transactions?
Yes, absolutely. Yes, as long as you are looking for the last ID you inserted. Okay.
So you wouldn't get the thing for top A card that's William Park, but you would get something from Jody Whittaker.
Yeah. Of course, this is also one reason why you should be careful if you have automatic reconnection, okay? In case the connection is lost, maybe your library will automatically reconnect to MySQL. But if it happens, this function will just return null, okay? So there are cases when automatic reconnection is kind of dangerous. Anyway, delete or update from many tables. Do you know this syntax? Almost no one. But it's still almost the same syntax as joins, except that you are not selecting, you are deleting rows or updating rows in more tables. Again, these examples will be available somehow from tomorrow and the next days. Okay?
I'm sorry, there was a typo.
Oh, sorry? No, because for an insert you don't join tables. Okay.
Insert into a table values using a select.
Yes, I will show you in a moment. No, but it's absolutely correct. Okay. So reading the data that we are deleting. Okay, we can even merge select and delete, but it only works on MariaDB. If you use MariaDB, you can use delete, blah, 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 returning, and then the columns that you want to read. Okay. Okay, creating a table with rows. So a table that is already populated with rows. Okay, we have two examples. First one is, first we create a table that is identical to another table, okay? So we are sure that the columns have the same definitions, data types, and so on. Then we run an insert select, what you asked about. You say insert into table name. What are you inserting? The result of that select. Okay? Or you can even merge them, so create table, select, blah, 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 blah. So you create a table that is suitable for keeping these results. Careful, it is not the same. Because in the first case, for example, you can have columns that are potentially big, like, I don't know, varchar 1000, but maybe they contain only short values. Okay? In the first case, we preserve the exact same table definition. In the second case, we just create a table that is suitable for these results, for the actual data. It could be what we want, it depends. MySQL and transactions. So we already mentioned transactions, but now we are talking a bit more specifically about them. Anyone knows what they are? Okay, half-half, more or less. So a transaction is a set of instructions. If you look at Wikipedia or a lot of other sites, they say that they follow the ACID acronyms, so I'm not going to explain, honestly. It's too boring. We will just see the practice. Okay, the practice is this. A transaction is a set of queries you run, okay? Once you run this transaction, you can be sure that it will completely succeed or completely fail, okay? So if, for example, you arrive at this point and the insert returns an error, depends on an error, but generally the whole transaction will roll back, okay? If it doesn't happen and you run commit and the commit succeeds, you can be sure that the transaction completely succeeded. Even in the case of a crash of MySQL, the transaction is somehow there, okay? When MySQL is restarted, some tables could be damaged, but they can also be repaired, and then all the transactions that succeeded will be there, okay? Notice that a transaction can start with start transaction, so it is an explicit transaction, and then it finishes with commit or rollback. Rollback is if you deliberately decide that the transaction must fail because you notice that there is something wrong somewhere.
What happens if I never send commit? Scripts crash and never send commit?
No, it will not crash. Actually, it depends on MySQL configuration.
My PHP is crash and never send commit.
Well, if your PHP crashes, MySQL notice that you are not there anymore and the transaction will fail.
So we roll back,
yes? Okay. Actually, the last case is the most common. So by default, the variable autocommit is set to 1, which means that every statement you run is a transaction. Okay, a one-statement transaction. So you could just make sure that autocommit is true, and then you run your delete, and that delete is wrapped in a transaction. Nothing happens outside of transactions. Okay, well, this is an example, but honestly, if I show all the example I made, we will run out of time. I'm sorry about that. But this is interesting. Transactions have the concept of isolation levels. Isolation level decides how much your work is isolated from the other concurrent sessions by other connections, other users, and so on. The default is called repeatable read. It means that for the whole transaction, there is a snapshot of the data you are working on. Okay? You see a row, you can update it, then you can delete it for some reason. You can be sure that the row is still there. You saw it at the beginning of the transaction. It will be there until the end of the transactions, unless you delete it. If someone else tries to delete it, the statement will be queued until the end of your transaction.
So is the table locked?
Not the table, just the rows. Okay. Sorry. A bit more relaxed is read committed. In read committed, each query acquires a separate snapshot. It means that you could see a row at the beginning of your transaction, then you try to update it, but the row is not there anymore because someone deleted it. Okay? You can run a query like this to use read committed. Why would you do such a thing? Because it causes much less work for MySQL. Okay. Generally, for any database server, setting a more relaxed isolation level makes things faster. Read uncommitted is actually crazy for most use cases because it means that you are querying data that potentially has not even been committed by other sessions. So another session inserts a row, it doesn't commit. You start a transaction in read uncommitted, you select that row, you see it, okay? Keep in mind that everything is possible. Maybe the other transaction will fail. You are seeing a row that will never exist. Sometimes you don't really care. I will show a couple of examples. Serializable is very similar to repeatable read, except that all selects are locking. When you select a row, that row is locked until the end of the transaction. So, okay, use cases for read uncommitted. Anyone has some ideas? Okay? Sorry, I can't hear you. Yes, yes, that's a good idea. Yeah. Anyone has other ideas?
Statistics.
Yes, absolutely.
It's like Corex or things like that.
Yeah, yeah, yeah. Sorry?
Right, I was saying like in Corex or things like that.
Yeah.
Select
Yeah. Okay. So yeah, I wrote statistics actually. Because if you run an average on 1 million rows, it doesn't matter if you are selecting a couple of rows that you shouldn't see. Okay, the result will not really change. Okay. Another example is if you need to show the typical message when one logins. Okay. Hi. Oh, yeah, these data were totally random. Hi, Teresa, your last access is on date, okay? No one will connect with the same username, hopefully, so you can use read uncommitted. If you need to delete all data, if you are not doing something wrong, horribly wrong, no one is actually reading that data, so you can use no one is actually even writing that data, right? They are old. This happens if you need to historicize rows in a big table from time to time and delete them and send them to another technology. Yep?
If you delete data that's in record, no, I guess that's my question by thinking about it, but if you delete the old data and you're outside of the transaction, will that affect what's going on inside the transaction?
No, you cannot outside of a transaction because everything you do is in a transaction. And okay, in other databases you can do similar things. You can start a transaction and then you can start a separate transaction with other, but in MySQL this will not work. Okay. Use cases for read committed. Anyone has some? Okay, let's see what I wrote. Okay, if you need to delete or update rows by ID from multiple tables, so you are sure that all the rows must exist. Okay, you are not afraid that someone could delete them. Show users payment history. Why? Because well, you don't want to use read uncommitted because that is a bit too unsafe for financial data maybe, but you can use read uncommitted because they are old data. They will not change. You can be reasonably sure, okay? Or maybe for each exam you show a list of the users who passed it. You can do this with read committed, okay? You don't need to acquire a single snapshot for doing such a thing, okay? And read-only transactions. I will tell this very, very quickly. Transactions can be read-only. This means that you can only run select in the transaction, and if you try to run an insert or a delete, it will fail with an error. Why would you do such a thing? Because you want your selects to return consistent results, okay? You select something from table, you select something else that is related into another table, and if in the meanwhile some rows were deleted by someone else, your read will be basically messed up, okay? So you want to do it sometimes in a transaction. So, ways to kill MySQL with transactions. Having a select privilege, so the permission to select from a table, is enough to kill MySQL or any other DBMS. Why? Because you can do this. You can start a transaction, select all the rows from a big table, then just wait 12 hours. And you are keeping all those rows, well, not locked, but MySQL has to keep track of the current state of those rows. And this will cause a lot of problems, and finally it will crash.
Wouldn't that get killed when the client goes away?
Yeah.
Sorry?
Wouldn't that get killed and the transaction roll back when the client goes away after 5 minutes of timeout?
Not automatically. But, okay, normally if the company has a DBA and the DBA does his job, at some point he will see some alert that the transaction history is too long, and basically MySQL will not survive forever, and he will kill the responsible, not the person, but the query. Okay. Because killing the person would be a too easy solution. You have to do it a hard way. Kill the query and hope it will not happen again. You can even run a select that is locking. Again, I cannot explain this syntax now because I would run out of time. So sorry guys, I will skip a couple of details. Okay. But again, in this case, we are locking some rows, so it will be even bigger problem. Okay. Advanced table features. This is usually a bit more funny for developers. Check constraints. Anyone knows what they are? Not many. So basically, they are this syntax and this. So what do? They define a condition that must be true, okay? This is a bit simpler. We check that the birthday is lesser than the death date, or the death date is null, so the person is alive, hopefully. If we try to insert a row, but this condition is not true, the insert will fail with an error, okay? No, PHP will not crash, and not even MySQL will crash. I mean, there will just be an error. PHP will receive an error from MySQL. Okay? The other condition is just a way to validate the email.
So you can keep check data on MySQL level, not on the PHP level.
Yeah. Yeah.
It will require more resources from MySQL.
It will, but consider a case when you have many applications that can write to the same tables. You want to enforce some conditions, but you don't trust that all applications will enforce the rules correctly, okay? Maybe it's not even possible because maybe some applications are proprietary and you cannot modify the code.
You want to keep the integrity of the database.
Yeah. Yeah. So yeah, it's true that this requires more resources, but you can do it. It's not a crazy waste of resources anyway.
Is it possible to kill MySQL with some strange check constraint?
No.
We can bypass it.
No, sorry.
Sorry, this is like a new feature? Like, if you go back, it's like, this is like a fairly new feature, right?
Yes, it's new. So MySQL 8 is the latest version of MySQL. MariaDB is not the latest, but almost, because the latest table is 10.3, I think. Okay. Computed columns. Anyone knows what they are? Not many. They are columns whose value is generated automatically, okay, as the syntax says. So for example, in this table you have the first name and the last name, and you can have a full name which is generated automatically with this SQL function. Okay?
What's the use case for?
I will mention a bit later.
Wouldn't that have more things, more jobs in the SQL job? I mean, from web development, you can get the first name, the last name, concatenate and the view, and you've got the full name. Why you should do that on MySQL and get some more resources?
Yes.
Something that we can already do on the view.
Okay,
Sorry, I also understand this is done during the insert, yes? Or not?
even if, yes, it is done during the insert.
If it's
But
done when the insert is saved, because the resources have 10,000 data or
okay.
data, it's take resources on the view, on the insert it takes milliseconds.
Okay, let me explain. There are two types actually of generated columns. This is, the default one is virtual, which means that the value is generated when you ask for it, when you run a select. Okay. The other type is if you specify explicitly persistent, and then the value is written on disk when you insert the row. Even if you update the row and change the last name, the generated value will change, but it will be done automatically by the server.
It's dynamic, it's like a view.
Yes.
It doesn't have a value itself.
Yes.
Can you apply check on generated values?
What do you mean?
Can you apply check on constraint? Can you apply the increment
previous slide on the generated values? On the previous slide, you showed
Yeah.
the check.
Okay.
So can you apply check
Oh, this check. Yes. Sorry.
on the generated values?
Yes, you can. You can.
So you can basically kill MySQL with check values.
Yeah, it's true. You can. But I mean, okay. It would be a bit crazy.
Well, so rather than just like shooting questions, maybe wait until the pub, because we could be here all night just on this issue.
Okay.
And we have to be out in like now. But yeah, but it's okay. I just don't want like 100 questions about this one issue, and we'll be here.
Can I maybe just finish this topic? Just
Okay.
just
Yeah,
generated columns.
just no more like we've already had like 50 questions about this.
So it's a couple of slides more, and then I finish.
Okay, fantastic.
Yeah.
Okay, thank you.
Yeah, sorry.
Sorry.
But I wanted to answer your question. It's true that you are adding work to MySQL, but there is also a case when you want to build an index on a virtual column. So in that case, you would actually make some queries faster, probably. Okay. Suppose that you have a query, suppose that you have a query where full name equals John Doe. It can use an index built on this column. And in MySQL, but not in MariaDB, it would also work for a query like where first name equal John and last name equal Doe. So there are maybe a couple of cases where it can improve performances. Okay. Default values, I want to show them just because they are very related. So what is the difference between a default value and a virtual column? A default value is something that is built on a SQL expression, okay? But it's not mandatory, okay? You can overwrite it. You can decide that the first name is John, the last name is Doe, and the full name is, I don't know, Genghis Khan.
Sorry. The full name should be more than 100 characters, because you have a space. You have 50 characters, space, and 50 characters.
Yeah. Yes, but it's a corner case if you have a first name of 50 characters and also a last name. But yes, you're right. So yes, again, the difference is that a virtual column generates a value that you cannot modify. A default value generates a value that is used only if you don't insert a different one. Okay? Okay, we can skip this stuff. So it was basically the last slide. Sorry, but everything took a bit too much time, technical problem, and good questions that I was happy to answer, but yeah, basically we ran out of time. Thank you, because you made it interesting with your questions.